Welcome to Embedded. I'm Alicia White, here with Christopher White. Our guest this week is Nathan Jones. We're going to talk about speaking and teaching.
Hi, Nathan. Welcome.
Hey, Chris. Hey, Alicia. Thanks so much for having me.
Could you tell us about yourself as if we met at the West Point Open House Parents' Day?
Do they have that?
I assume so.
They've got lots, yeah. I'd say I'm Nathan Jones. I'll probably be wearing my uniform, but for those of you that can't see me, I'm an active duty Army officer in the rank of major and an instructor at West Point. And if it's a parent I'm meeting, I'd probably say that I'm actually probably teaching your student either this semester or the one next in either cyber fundamentals or intro to physics.
I have more questions about that, but you also are giving a few talks in the next month. Next week? Oh, next week.
Yeah, coming up.
What are your talks about?
I'll be speaking at the Teardown conference in Portland, Oregon, and the two proposals that they accepted were a talk called Make Your Own MCU Boards, where I'm just going to share some tips that I picked up in taking a microcontroller and just putting it on a breadboard or on a printed circuit board. And I wanted to hit the easy button, so I submitted a workshop proposal to just take some folks through a HackerBox kit where they're playing around with the PIC microcontroller. So thankfully, HackerBox is donating all the kits. I just got to show up and help folks play around with PICs. Will
you show up in your uniform?
No, I'm not really going in an official capacity. This is kind of more just it's the reason I'm embedded. I just love learning myself and love sharing what I learn.
Are you ready for lightning round?
Is anyone ever?
We're never ready.
Let's go.
We're not very good at it. Largest vehicle you've ever driven?
Driven? It's probably nothing crazy, just a personal vehicle, but I've been able to ride in C-130s and Chinooks, and I'm airborne qualified, so I got to fall in out of a couple of helicopters. Yeah, that's the big one with the double rotors.
Largest vehicle, ground vehicle you've ever sat in?
Probably just a coach bus. I mean, nothing huge.
I got him beat.
Christopher's been in a tank.
Oh, yeah, you do. Very nice.
Maximum number of push-ups you've given a student for getting something wrong or doing something wrong in your classroom?
The grads I find are way more strict in the classroom. But since I didn't go to West Point, I'm a very laid-back individual. I've told my students before, like if they walk in and they're like, "Hey, sir, it's going to help me study better if I just take my boots off and get comfortable," I'd be like, "Drive on, let's do it." So probably 0.
What is the proper pronunciation of hua?
Hua!
What's your favorite embedded processor for use by college students?
For like a college course?
Yeah.
Honestly, I think I would go with either the PIC or the MSP 430. I think the architecture is simple enough that you can kind of really get your teeth into the data sheet and understand it, but there's still lots of support.
I'm sorry. Worst MRE you've ever tasted?
Oh, God. It wasn't as bad as people thought it was, but the cheese omelet was really
God.
It's every bit as bad as you think of it, as you're thinking of it right now.
What's your favorite fictional robot?
Okay, I want to let you know, I thought long and hard about this.
Listeners are the best.
It's Deborah Bot 3000 from Mitchell's versus the Machines.
Oh, gosh,
that's a new one.
I don't remember that one. We saw that movie, but I don't remember that particular robot. I have to go back and look at it.
It's one of the two comic relief robots that follows with the family on their adventure.
Oh, right. Okay.
That was a good movie.
Yeah.
Right.
Yeah, stupendous.
What is your favorite tool for schematic capture?
I am most familiar with Eagle, but I've had the luxury, I think, of the last 5 years of being able to lean on a lot of educational licenses. So I hear really good things about KiCad, and honestly, I ended up liking a lot of just browser-based tools. I know it's not the heaviest lift, but they're just it takes away a lot of the pain of having to install anything.
And do you have a tip everyone should know?
Yes, although I'll tell you, ChatGPT stole mine, the one I was going to go with, which was just take a break. that was like, I called that my superpower in grad school because there's a lot of really good science behind that. But the one I'll go with instead is if you take a public Git repo and you change the first part of the URL from github.com to github1s.com, you'll open what looks like an instance of VS Code in your web browser. You can navigate the repository.
I've got an addition to that, which is a very good tip.
Really?
But if you are on a page, if you're on a GitHub repo, and you're in github.com, and you just type period, it does that.
Yes, it's
No
beautiful.
way.
Yeah.
Yes, it's
Nice.
awesome. All right, let's, first of all, I mean, we know what West Point is, and your brother went there for a little while.
No, he went to the Air Force Academy for a little while.
I suck so much.
And then he did ROTC for the Army.
Okay, but I knew the tanks for the Army, so he did do, okay.
He was in the Army.
What is West Point for folks who don't know?
West Point, the full name is the United States Military Academy. So it is a part of the Army where students go to earn not only a college degree, but also to commission as second lieutenants. And it's kind of a neat institution. The whole place is set up to take high school graduates and turn them into officers. So they call it the 47-month experience from when they show up to when they graduate. They've got their time kind of all planned out, taking college courses and doing military training. And when they exit, just like our ROTC cadets will, they'll put on the rank of second lieutenant and perform some job in the military.
And it's very competitive.
Yeah, extremely.
Okay, so how did you become an instructor there?
I think I got cold called like a blanket email as a first lieutenant when I just been in the military for a couple of years, based on just my degree, getting the engineering degree from Harvey Mudd. And so I always knew I always had a thought that I would enjoy teaching, but I needed to try it out. So it was kind of on my radar for a long time. And when I finally sort of got in that window in my career where it was going to make sense, I worked as hard as I could to get it, and the stars aligned, and I was able to go to grad school on the Army's dollar, and then spend the last 3 years here.
Alicia is just remembering that you were a mutter. Somehow that slipped her mind. Otherwise, you would have gotten a lot worse lightning round questions.
What did you go to grad school for?
I ended up getting my degree in computer engineering, but I wanted to do embedded system stuff, and really it was there's a professor there at where I went at NC State named Alex Dean, and he's got a couple of trio courses that are just very, very embedded focused, using the KL25Z. At least it was when I was there, and then another one kind of getting into embedded Linux, and so it just really worked out that I was in that area at the time. I was stationed at Fort Bragg, and my wife was working in Raleigh. And so it really worked out well to do that for my master's.
And what was your degree at Mudd?
It was in engineering.
All right. And for those of you wondering how you can get a degree in engineering, it's a good question. But
What?
you can.
What's wrong with getting a degree in engineering?
You get electrical engineering, mechanical engineering, computer engineering.
Engineering.
Well, there's only a half dozen to choose from.
You never know when you're going to have to combine electrical, civil, and chemical engineering in a single job. Yeah.
All right.
Well-rounded engineers and scientists who understand the impact of their work on society, you know?
Oh, come on. You sound like an ad now.
I gave tours for a year or two. I mean, I love that school.
So you have been giving a lot of talks recently. You have the 2 upcoming for Teardown, which are very close. And you recently gave 2 for the Embedded Online Conference for a total of 4 totally different talks.
Yeah.
That seems like a lot. I mean, I know how long it takes me to prepare talks. Are these part of your lectures for class, or are these fully prepared talks?
Fully prepared. I try to often to make the work stuff align, but at this point, I mean, I'm still really new to like the whole conference stuff. I mean, the first time I presented was at Hackaday last November. So at this point, I think I'm still really just like, you know, I'm like the guy on the red carpet that's just happy to be there. Like I'm trying to find the proposal that I think has the highest possible chance of being accepted. And I'm as giddy as this cool kid when I get an email that says, "Hey, we're happy to have you."
What has driven you to start speaking in public?
When I was in grad school, I think I discovered that there was a desire to do that. I mean, I didn't do too much embedded stuff, really, when I was in the military, even though it was still, kind of a latent hobby, a latent interest. And when I got to go to grad school, my job full time was to just go to school, get my degree, and play around with electronics. And so it kind of reawakened just that love of putting stuff together and tackling difficult challenges. Chris Sveck came to talk to the embedded systems class that I took from Alex Teen, and that's when I first heard about the Embedded FM podcast. And so I started reading a lot and just wanted to do that. Wanted to be be able to see my name on a speaker panel, and maybe not in any tremendous way, but be able to say I was contributing to the body of embedded systems knowledge. So I applied to a couple, when I was in grad school, and it all got turned down. And I think it's just one of those things you just, the world rewards those who are too dumb to quit. And so just kept applying, kept trying to think of fun talks that would be accepted. And Hackaday was the first one. That was just a dream come true.
What'd you talk about for Hackaday?
I led a workshop called Beyond Arduino. So trying to get folks just set up with like the STM32 environment and kind of blink some LEDs and maybe talk to a I2C light sensor using kind of the CubeMX software. And I think a couple folks got there. It was maybe a bit ambitious to bite off in a couple-hour workshop.
It is. When people bring their own computers, they have a base level that is totally different. And it's hard to run around and try to help everyone when maybe you don't have the experience in their particular brand of Linux or Mac or...
Yeah, well, and I ran into the issue too where I was, in order to get done what I wanted to get done, there was some stuff that I was thinking that a lot of folks would do ahead of time in terms of at a minimum sort of installing certain pieces of software and, being able to, right? So a lot of folks showed up just kind of being like, hey, the title sounded cool, here I am. And so not only are they trying to install software and I'm walking through stuff, but I think I wanted to give them a little more than we had time for. And so instead of saying, here's this code, run it, and later on you can kind of pick it apart and see how it works. I tried a little too much to help kind of walk people onto, here's where you find the data sheet, here's where it shows you what it is, here's how you pull up the reference manual for the CubeMX, like their HAL, and how you find which functions are available to you when you turn on a GPIO in the code configurator. And I think that was not a good sort of format for like the workshop.
I went to a workshop years ago at one of the embedded conferences where they had a bunch of Raspberry Pis hooked to monitors, and they all had the tool set up. And then you took your Raspberry Pi home. Not the monitor, of course.
Right.
But that was kind of a genius way to solve the tools to me, because it's so hard to have everybody have the same thing. And yet most things can compile. I mean, for an STM32, you can compile on a Raspberry Pi. Takes a little longer, but who cares?
Yeah, exactly. And I'm not an expert in any of them, but I know that, or it's my understanding that there are lots of options too in terms of Docker environments or even sort of in-browser kind of setups. I think my big takeaway was just that, you think of a workshop as being 2 to 4 hours, and you think, oh man, I can get a lot done in 2 to 4 hours, but it's not the time to like try to push a lot of information. Even though it seems like a long time, it's the scope needs to be much more limited than you think it needs to be to give folks time to kind of play around and experiment and try and fail and still feel like they accomplished something.
How about your embedded online talks? There was a short one and a long one. Which was the long one?
That was object-oriented programming in C.
Okay, why is that still a talk? I mean, no offense to you, but is that news to anyone?
I hope not, But I'll tell you, I did still get a lot of questions like why C and not C++. For me, it was just, again, going back to the talks that I'm presenting, going through grad school, was learning some of these things. I took some time to assimilate a lot of the resources and techniques that I'd read about into something that I felt like when I could say I could talk about object-oriented programming techniques using kind of strict C. And I don't know, I just thought it was a cool project, so I proposed it and it got accepted.
Well, let's talk about that a little bit in a little detail, because I think people do respond to that, and people listening to this may respond to that with, what are you talking about?
Pointers?
C isn't object-oriented. How can you do object-oriented in a non-object-oriented language?
Yeah.
So what is the deal with
Give us the 3-minute version.
Yeah. So,
or the 10-minute version.
Well, I'll tell you, originally I was misguided in terms of, like, early in my programming career. I thought OOP was sort of like, once you learned for loops and while loops, that was sort of the next step. And I'm gradually learning that that's not necessarily the case. It was only after I'd sort of picked all this up that I'd come to realize that. But it's a paradigm. One of the three big ones, right? There's procedural, object-oriented, and functional. And when you say object-oriented, people think of languages like C++ and Java that are, well, C++ and maybe both you would say are sort of multi-paradigm, but they have built-in language features that align well with the idea of being object-oriented. But it's not the specific purview of those languages. Object-oriented programming includes the principles of abstraction, encapsulation, polymorphism, and inheritance. And you can do all of those in C. Of
course. And for embedded systems, it makes a lot of sense, because you talk about an object and you talk about an accelerometer. There's your object.
Exactly.
I mean, it's a real physical object, so it makes sense. But
yeah,
when we talk about a sensor class that has an accelerometer that is a child of it inherits this. The accelerometer inherits the sensor class. When you're not using C++, that does seem to be mostly function pointers.
Yeah, at least, in the notes I put together, once you want to play around with like runtime, polymorphism, or inheritance, it kind of comes down to that. But it's my understanding that that's exactly what the C++ compiler is doing under the hood anyways. It's just, you have to do it explicitly in C.
There's no free lunch.
Exactly.
Computers work the way they do.
You said you have notes about it. I saw you had a GitHub repository with increasing levels of examples of object-oriented in C.
Yeah, that's how I think. When I put my notes together, I want to sort of structure it in a way that makes sense. And for me, at least, the way to kind of approach this topic is in terms of what's the easiest, simplest thing to kind of understand and implement, and how do you build more capability from there. And it turns out that it's not hard at all. Most people are already incorporating some form of abstraction or encapsulation in their C programs. And the repository, I sort of break out polymorphism into polymorphism at build time versus polymorphism at runtime. And even just doing sort of a build time polymorphism is not hard. The idea that I can sort of write application code to talk to a temperature sensor, even though I don't know exactly what temperature sensor I'm going to use, and I can leverage either the preprocessor or the linker to, when I finally build my project, provide the necessary functions to complete the project. And when I write my code in that way, I get a lot of benefits.
That makes sense. But when I look at your site, it looks like you're doing design patterns.
Yeah, absolutely.
But that's not necessarily object-oriented programming.
No, not necessarily. Hopefully I don't show my ignorance here, but it's my understanding that like some of the traditional design patterns that are in like the Gang of Four book, they sort of assume an object-oriented language.
Yeah, that's right.
Which is not to say that, like you said, Alicia, the design patterns require it. One of my favorite books is Design Patterns in Embedded Systems in C, I think, by Bruce Powell Douglas. Mm-hmm. And he uses the term just like you might think kind of more generally as a solution to a commonly found problem. But I find it really cool to, once you start picking up some of the OOP techniques and particularly the idea of being able to kind of substitute implementations either at build time or runtime, that it does open up the possibility of the more classic design patterns, and that to me that definitely kind of levels up your code, your ability to write complex application software when I know how to leverage the observer pattern or the strategy pattern or the template method pattern to get this done.
Do you think that design patterns are important more because of the way people think about code, the way people communicate with each other about code, or the actual, I'm learning this because I need to solve this problem?
I want to say either the first or the third. I mean, I feel like one of the interesting things to me about software is that it's possible to write 1,000 different different versions of source code that all functionally do the same thing. So I feel like it's easy when you're looking at code and that's kind of like your main interface to writing software. It's easy to kind of get lost maybe in the details and how to actually solve the problem. But if you can look at a piece of code and know that I'm going to apply the template method pattern here, or know that someone else, they're using a callback. This is a callback mechanism, or it's an observer pattern. Then, what is just a sort of dozens of lines of text takes on more of an architectural view.
There's a good body of work that shows if you don't have the words for something, you can't understand it as well. So people who are challenged with language in one way or another don't understand the concepts. And so having the words for the design patterns does help just making the concepts available to you.
Yeah, absolutely. You're totally right that if something's kind of ineffable, then it's hard to think about it. Like if you can't put words to it, then you can't construct a mental model around it. And so once you've sort of mastered the basics of the language and just control flow and some basic modules, learning how to build those up into architectural patterns is one way to sort of start building larger and more complex pieces of software.
But you work with students who may have a little bit of computer background, but aren't necessarily expert programmers or experts in embedded systems. Where do you start teaching them these abstract patterns and methods versus having them truly understand what a conditional is?
For the classes I've taught, it's definitely much more of the former, the latter, in terms of just sticking with the basics. I think if given the chance and had the opportunity to teach more of the kind of upper level embedded systems courses, I wouldn't necessarily introduce it as like, here's a design pattern, we're going to talk about this, but just showing them a piece of sample code and the benefits of the code being constructed the way it is, in terms of probably to start with just the idea of kind of keeping details hidden behind an abstraction and talking about how we're able to write code that doesn't interface with peripheral registers directly maybe, but at least through sort of a wrapper layer so that if something changes in the future, it's not difficult.
Yeah, the wrapper, as far as design patterns go, the wrapper is by far the easiest to understand and to communicate. Because it becomes obvious the second time you have to port something.
And even then, it's hard to, even though it's easy to conceive of, it's often hard to do it right. There's plenty of wrappers I've seen implemented myself that, we did that and we hoped we'd be able to port stuff, but when we came time to do that, that's not what we did.
You passed too much information or not enough.
Right.
Yeah.
It just wasn't right.
Yeah, but at least he's right. I mean, all it takes is, having to make one change in your, all it takes is having to change one value in your software to be like, oh, okay, there's no magic numbers. Everything's const or pound defined because I'm not control Fing this thing again.
Yes.
How do you learn more about object-oriented and design patterns? Do you have a way to stay current?
For the object-oriented stuff, my big resources were, there's a chapter in James Grenning's book on TDD where he kind of builds up a couple of object-oriented techniques. Mira Samek's got a PDF out there where he talks about kind of the underpinnings of his QP framework. I cut my teeth on a PDF called OOC by Axel Schreiner, where he builds up basically almost like the full C++ in C, which was really daunting. So that definitely accrued kind of over time as I tried to kind of wrestle with this stuff. There's a great book on design patterns called Head First Design Patterns.
Yes.
It's actually for
That's
Java.
my favorite. Yeah.
Yeah. But knowing what I knew about OOP and C, I was able to do everything in the book, with C stuff. That helped me kind of understand what those design patterns were doing.
How did your talk go over?
I think it went over really well. The Embedded Online Conference does some statistics tracking, and I think there were a lot of really positive responses. I got a lot from this talk. I got a lot of very similar questions like, why are you doing this? Even from my coworkers, I sent an email to one of them to ask for some assistance, and they were like, why aren't you just using C++? Got a lot of these questions, but I think one thing I tried to really impress on folks was just kind of like we've been talking about, that some of the simpler stuff of just kind of keeping stuff abstract and be able to substitute modules, even just with a little linker flag to say, hey, pull in this source file, not this one, really gives folks a lot of benefits, and those allow for really good modular code, which is not the purview of C++. It's been well studied since the 70s, is being able to be easier to design and test and write and change. And so one thing I hope folks took away was just a couple of ways that they can write really good modular code.
It's not like C++ makes you a magical object-oriented programming wizard. I mean, there's nothing about C++ that makes you be able to see all of these things. In fact, the conditionals are just the same. Mm-hmm. So I have on my list, why don't you just use C++? But the truth is, you still need to understand the concepts. You can't just go into C++ and expect to understand polymorphism and inheritance. Those words may exist more there than in C, but C++ compilers can be written in C. So there's nothing you can do there that you can't do here.
Yeah, exactly. And I feel like even if it ends up just being sort of an educational exercise, knowing how to set up the polymorphism and the virtual functions and what sorts of things you can do makes what the C++ compiler is doing, I think it makes a lot more sense.
Oh, yeah. Yes, understanding makes things make more sense. That's sort of a tautology.
I would also argue that C++ is maybe not the language to learn for object-oriented to start with, period. Like, it might have been the only game in town for a while in the 90s. Have the
Rust people gotten to you?
Rust is not object-oriented. Rust is not an object-oriented language. It has some object stuff, but it's not. It's more like C with some object stuff. But no, it's gotten, it has the weight of, I don't want to know, 20, 30, a lot of years. And it's accrued a lot of stuff. And so I think it's daunting to approach learning a new paradigm of programming with the most kitchen sink programming language with that thought behind it. So I mean, even Java's older, or not older, but it's in similar vintage. It's newer, but I think perhaps that's an easier way to go. Python, I don't have a good suggestion, but there are more streamlined object-oriented languages that have come along since C++ that would be a better place to start with, especially since having come after C++, they de-emphasize some of the things that people have come to realize were not necessarily things that should be commonly used. Let's put it that way. Multiple inheritance, that kind of thing.
Yeah. Well, and isn't inheritance itself just sort of like kind of discouraged now?
Somewhat, yeah, but that's kind of a murky discussion. But I mean,
should have a has a instead of an is a.
Yeah, composition is preferred, but you still can't get around inheritance in certain cases. Like Swift is a language that very much is against inheritance and would rather you do it different ways. And yet there's the foundation libraries are all using inheritance all over the place. So, and protocols which do stuff like inheritance, but it's not inheritance. Yes, there's ways around inheritance, but I guess they're trying to push it to be something you do only when necessary instead of something you reach for immediately. But C++, that was kind of the thing, right? When you first started using it. And I think newer C++ is also de-emphasizing it, but it's kind of hard now that it's this big, giant language with this history. Somebody's going to yell at me.
And there's so much, I mean, in order to do that, from my understanding, I'm not an expert C++ programmer, but in order to be able to do those things, there's a lot that the compiler is doing for you. Mm-hmm. A lot.
Yeah, and when you start talking about embedded systems, that's when you start talking about which things do you not want to be doing because it might be take a lot of space or CPU time.
Okay, so you have a GitHub repository for that. You also have a GitHub repository for your other embedded online course, online talk, which was about command line, which I have to say, I feel like I've given that talk, but I don't think I ever have. But it was very familiar and I liked it a lot.
Didn't you write a chapter in your book? So, I mean...
part of a chapter. But you are getting ready to give a couple of more talks. You mentioned the HackerBox Pick of Destiny, but what I want you to tell me about is make your own MCU boards, because it's weird to go from object-oriented programming to make your own boards, where weird is embedded systems.
I take that as a huge compliment. I have a great memory of going to some Army training and walking in one day with my motorcycle helmet and having someone look up and say, I really don't know who you are. Yeah, I just, the thing that I love about embedded systems is just, well, I think it's in your book, Alicia, the first edition. You say the first time I turned a motor because I told it to, I was hooked.
Yeah.
And that's what I love. I love the idea of just creating these enormously complex and amazing devices out of, some circuits and, some few lines of code. So, yeah, I try to make my projects kind of line up with work where I can, but if not, I just, when I was in grad school, I thought, hey, I need to learn OOP. And so that kind of started this journey and, of putting those notes together. I had an experience in between my 2 years in grad school where I sat down because I was going to put a little project together and realized that I had no idea where to start if it wasn't on the development board we'd used in our embedded systems class in the IDE that we had been using. And so that started a, multi-year kind of journey to sort of say, okay, if I was starting from scratch, where would I go? And part of that journey took me into, okay, how do I actually put microcontrollers on a breadboard? What is the circuit that I need to be able to kind of talk to these things? I'm no expert PCB designer, but in playing around with stuff, I feel like I saw behind the Iron Curtain and realized that there's a lot to it. It's not as difficult as it seems like at first pass. Was able to just lay out a couple of really kind of cheap dev boards that could get assembled by JLC for a couple bucks, and wanted to be able to share that with folks. So I'm going to take a half an hour just to kind of hopefully help share with them that it's not as hard as it seems.
Which MCUs are you talking about?
I'm going to keep it really general because it turns out that I think unless you get into like application processors, the themes all end up being very similar, which is that the microcontroller needs power, it needs a clock, it needs a way to program it. And a lot of that stuff happens internally. So you can load code onto and run code from an STM32 with nothing external to it except a regulated power supply. So I kind of show, I'm going to use that one because that's when I put together my last project, I was using that because I wanted to make a sort of a not competitor, but an alternative to the blue pill for folks that cared about whether or not their electronic devices were counterfeit or not. And so I'll be using that. And then I've just been doing some stuff recently with the pick, so I kind of show that. But I try to stay very general. So it's just I got a couple of notes that I'm going to walk folks through to kind of show them what that stuff looks like.
Are you using documentation from the vendors primarily, or is it stuff you've synthesized?
It's primarily stuff I've synthesized because a lot of the talk is going to be tips on where to find parts and how to use assembly services and things like that to kind of actually go into construction. But definitely, as far as I've seen, every manufacturer in some form or capacity, when you pick a microcontroller, there's somewhere in the documentation where they say, here's kind of the recommended circuit. And, ST's got a bunch of great documentation. So they, like many others, have entire app notes devoted to just, if you've got this microcontroller, here are our recommendations for how to lay it out.
Are you going to talk about Eagle or some other schematic capture for using this?
That's one of the things that I'm going to have to say, hey, if you don't know PCB layout, we're not talking about it here. So I don't even think I show any screen captures from my projects. I think I Googled for some generic PCB layout for the spot where I'm saying, here's where you take your circuit and put it on a circuit board. There's a couple other things like, hey, if you really got to deal with low noise analog stuff or, you're trying to make a USB connection and you're kind of worried about high speed signals, that's a topic for a different day.
Antennas too.
Yeah.
Do you have a philosophy about slides?
I try to use them as little as possible.
I try to avoid words.
That's not very Army. Sorry, I've seen some Army presentations.
Yes, I know. I try to avoid words, and I try not to have it be the outline. But as soon as you said, I've seen some Army slides, and I'm like, me too. And usually they're basically books in PDF form.
Yeah, for as difficult it is to get into West Point to complete ROTC, there's the Army likes to cater to the lowest common denominator, as do many of the military services. And I've learned a lot over the last couple of years in just what are effective ways of communicating information to people, and in teaching that. I think it's a really neat field. This the idea of science of learning, pedagogy, andragogy, like how do people learn? And what I've read is just that that's actually pretty well studied. That the text in very specific ways can kind of enhance a presentation, but otherwise it more often than not ends up competing with what the speaker's trying to say. And it's much more effective to be able to present a visual to someone as you're speaking over it to try to relay information. I got really excited about a year ago with an organization called the Modern Classrooms Project, which is just one method of teaching that tried to bring some kind of more modern teaching practices to the classroom. And they really recommended short lessons, as little as 5 or 10 minutes, because that's really all the attention span people have if they haven't specifically trained it. And what I ended up kind of doing is I've gravitated towards taking a landscape 8.5 sheet of paper in OneNote, but effectively that same size, and just kind of sketching out graphically what are the main points. Like if folks were to sort of take a step back and look at this sheet of paper, they might not get all the details, but they could point to kind of the landmarks and say, yeah, that was covered. Sort of a cross between a mind map or something that would just take kind of the high points and kind of annotate them in a more graphical way. And I try to keep myself, because I feel like if I find myself spilling onto a second page, then that's an indicator that I'm trying to fit too much content into my talk.
I often will try to balance what's on the screen with what I'm saying. For example, if I have a complicated slide, then what I'm talking about for a while is going to be more amusing, lighter, less technical. Mm-hmm. And if I have a picture of a monkey on a slide, I'm probably talking about something very technical and I just want them to engage. And the monkey is there so that they don't get too bored.
The monkey's on a slide? On the slide? Is a monkey on a slide? Never mind.
Oh, I don't have a picture of that, but I will be making one. Yes. The monkey will be on a slide, sliding down a slide on the slide.
I don't know where these techniques are very good, and I don't know maybe it was Alicia telling me what to do back in the early days of when I had to give presentations, but being able to separate what you're saying from the slide was a revelation. It's like, oh, my notes and what's on the slide can diverge. I don't have to put all of my notes on the slide and read them, because what's the point of that?
If the people you're presenting to cannot read, then they're not likely to be able to use the information you're giving them.
So only put stuff on the slide that cannot be conveyed in speech easily. Things that need to be visual, connections, things like that. And sometimes a list of bullet points if you're really,
at the end, just to make sure they remember.
Yeah, I think that's how I think of it too. I think of what's the piece of information I'm trying to convey. For a talk, is it here's how you construct a for loop. Then I ask myself, what is the thing that I would want to see, that hearing the speaker say the thing that I'm going to say, what is the thing I would want to see that would help me go, oh, okay, I get it. And it might be like a templated for loop, or it might be a little, GIF of a for loop in action, watching someone kind of step through. Here's how the index variable changes, and that you can see the program counter kind of go back, or the little finger that points to where we are in the code kind of iterate that many number of times.
Going back to West Point, and you personally went to a college that prepares students for grad school or industry, often industry. And at West Point, the students aren't being prepared to go to an industry job right away. It's like they already have a 5-year plan. Mm-hmm. Whereas at most normal colleges, it's like, oh, I'm graduating this year and I have to have a job. Oh no. Does that make your job much different?
It does, definitely. I think the students, they still see themselves as engineers, and many of them have career goals that are not in the too distant future. The only requirement once they graduate West Point, unless it's changed, is 5 years on active duty and then maybe some amount of time in the reserves. So many of them are still kind of thinking about, really still being new professionals and looking at these kinds of jobs. The way where I think it affects it the biggest, and one that I'm probably going to miss a bit when I leave West Point, is just the idea that even though I'm teaching them about programming or electronics or physics, that education is serving the purpose of helping them become a qualified officer. Someone who's going to be able to take command of a formation and lead that formation well. You'll be able to say that I'm in charge of someone's son or daughter, their brother, their sister, and handle the tasks given to them in a way that honors the soldier. So it's neat. I picked up a technique from coming in from a couple of the older instructors that they called broadening bits. It was just kind of starting or something called the military minute. You sort of start class with, either a current topic, or I end up spending a lot of my time discussing with them just life skills that I feel like I picked up that are perception, thoughts and thought patterns that have really helped me. And a lot of students end up telling at the end that, that those end up being the one thing that they kind of remembered about the course.
You had some questions you were going to ask us.
Yeah. So I want to maybe primarily to you, Alicia, I want to ask first about how the book's coming. So I've been seeing lots of fascinating discussions on the Slack, and I'm super excited for the second edition. So how's it going?
It's going pretty well. Thank you for asking.
It's not a setup.
No, not exactly. It is supposed to go into the early release process on Tuesday, which may mean that by the end of June, it will be available on the O'Reilly website as early release. But that's just the first 5 chapters.
How terrified are you of that?
And I am adding 2 more chapters. So there'll be a total of 12 instead of 10. And yes, I do talk about it on the the embedded Patreon Slack, because it is so nice to be able to ask people, like, do you have problems with this? Should I write about it? And I mean, when I first wrote the book, I had all of the problems that I'd ever had, but it didn't occur to me. Some problems people have often didn't penetrate what I had done. And it's so nice to be able to say, okay, so these are the titles. Which would you read? And does anybody care about localization? So,
have you found yourself like being able to draw a lot from just old projects and old notes, or do you find that there are topics where you're like, I really felt that I should have included this in the first edition, but it's not necessarily one that I know a lot about and need to sort of learn a little bit before I'm able to include this section in the book?
I knew I wanted to include more design patterns, and those actually fell in pretty easily. Teaching the class part class helped a lot because people asked more questions, and I prepared lectures as they asked questions. And so I had more material that way. There wasn't a lot at the time that fell out that I wanted to put in. I mean, I kind of just did, that was the state of my brain entirely. But there are new things now that I wish I had known then, even if it was just the terms. So yeah, it's going along. It should be out in the fall.
That's awesome.
Of some year.
No, of this year. Of this year.
Keep your, hedge your bets.
No. Although I should have worked on it today and yesterday, the day before, instead of having a weekend.
This was mostly selfish, but so I will be, I think, transitioning out of the military in a couple of years because I love teaching and building electronics way too much not to do it. But that'll be the first time I've ever had to shop for a job. I did ROTC, and for the last 13 years, the Army's just told me where to go. So I'm a little bit terrified of that. I'm curious, the two of you, reflecting back on your careers, what are some of the things maybe you would look for in an employer? I mean, does the field really matter? Is it all just, fun embedded stuff, regardless of whether you're working for ag or space or automotive, or, are there specific things that maybe you didn't look for initially, like companies that would send folks to conferences or something like that you prioritize now? I
like applications. If at the end of the day, I don't want to take home the application, even if it's something I can't take home, like a robot or something, I don't want to work on it unless I really like the application. I don't manage to stay engaged. And I wish I had stayed with some of my better bosses. I wish I had put a higher priority on having a really good boss as opposed to having a really fun job.
Yeah, it's a tough balance. I echo her applications matter thing. There is definitely some jobs with some applications that I wish I had not engaged with. There were some that I was just sort of bored with, and they're totally fine, but they were just jobs and writing code for a nebulous black box that moved bits from one place to another and that kind of thing. But those were sometimes the application and the company culture were not aligned. So you could have a very interesting to you application with, that had some social impact that you were happy about, and the company was totally toxic. So that's really tough. And that's the thing in recent years that I become more concerned with. I mean, I wouldn't take an application that I'm not comfortable with, but I'm also concerned about, let's just say, executive staff. Because I think some weird things have been happening in companies in the last 10 years. I think some, for lack of a better way to say it, some weird people have gotten into the upper ranks of organizations. And having encountered some of those people and had to deal with them closely, I am now much more wary of corporations in general. And so if I were to go looking for a job, the full-time job or a large-scale contract with a company, that's sort of beyond the 2 or 3 person startup size, I would be looking very carefully at kind of what I could find out about the company culture, who's running it, what their attitudes towards certain things, because I've become very cynical about that whole aspect of the industry. That's not a positive thing, sorry. But
well, what I would say is, I mean, it reinforces just the idea that so much of the job is affected by your the management, kind of at all levels, but like at least you were saying too, just even your immediate supervisor, your immediate boss. I feel like it's one of the things that I share with some of my cadets that I say is, in my experience, your soldiers can openly dislike you, but like the impact that you have on an organization being the actual leader is still enormous. Like the way your personality and the things you value are the things that matriculate down through the organization.
Yeah, and if there are people who aren't comfortable with that, they end up spending a lot of their time protecting the people below them, trying to, deflect and diffuse some of that toxicity or leadership gaps and things. But maybe they're not in a role where, they're in a mid-level or lower-level leadership position, and they're not, able to kind of right the ship against, senior manager, that kind of thing.
I would add to the list of things to consider when looking for a job. There are all kinds of jobs out there. And I have been pretty lucky that I generally have fell into jobs where they worked for me. When I wanted to have a startup, when I was willing to put in a lot of work, I went to a startup. Even when things I didn't know I needed, I got from work. But I've seen other people struggle because they're just in the wrong job and they don't realize it. Mm-hmm. If I had gone to, after HP Labs, I had the choice between going to a 50-person startup that was all guys and I knew was going to have problems with that, or to a 300-person, reasonably well-established medical device dealing with chemicals, and I had some weird ancillary skills that they were very excited about. And I went to the startup, and I'm glad, because now that I think about how medical companies work, of that size, medical companies of that size particularly, they don't work fast. And I was at a position that I wanted everything to go really fast. I wanted to be the hummingbird. But now I'm working on Science Gear, and they said, well, we need this by October. And I'm like, okay, I could have it for you next week, but October's fine too.
2025.
And then the next thing was, and then we need to test it in the field in the spring. And I'm like, why would you need so much time? Once we get it in October, we should take it out, next day.
Because they only have 3 boats and they're all booked up until spring.
This isn't deep sea, so it doesn't have to go on the boat. But yeah, so if you find you're in a job that isn't suited for you, don't give up on engineering or embedded systems. Yeah. There are fast jobs and there are slow jobs. There are jobs where you'll learn a lot, and there are jobs where you can coast on your skills and still be useful to the company. And you'll need more of these throughout your career. There are times when you do need to recharge, and coasting on what you've done is a good thing for 6 months. I wouldn't say it's a good thing for 5 years, but if you have a family and kids, maybe all you need is the paycheck. And as long as you're doing enough to make them happy and enough to make you happy, work does not need to be life.
Yeah. And to add to the culture thing, things change. That's the other thing, is you can get into a company that's awesome and be there for 3 years and super happy. And then suddenly it's, what happened to this place?
And that's okay.
And that's all right. And
you don't have to stay.
Yeah, you don't have to stay. That's what I'm trying to say. It's like, coming from the Army, it's like, okay, this is very stable. I've been here for 10 years. Maybe you're a person who stays at companies 10 years. Maybe you're a person who, 2 years is enough at any given company. And then I want to move on to something else. And that's something else to figure out about yourself.
At that point, I've learned a lot and I've contributed a lot, and I'm not learning anymore. So I'm going to go find someplace else to play.
Yeah.
Do you want an engineering job or do you want a teaching job?
Yes.
That's a little harder.
I know. The current kind of tentative plan is that eventually I definitely will teach. But right now I feel like I would like to be able to say that I had some experience, shipping products or equivalent. So the thought is that I would work for 5 or 10 years somewhere doing that. And even that list of like things I'm looking at, it's a lot of them are organizations that have a teaching component to them anyways. And then go back and get a PhD and find somewhere to settle in and teach.
Would you go back to Mud and teach?
If the school were not in Southern California, I would move in a heartbeat.
You mentioned that you teach your students and they become leaders. Mm-hmm. They don't go into industry and become engineers. They're already suited to basically management?
Yeah, pretty much. It depends definitely on what they branch. So there are lots of traditional branches, infantry and field artillery and military intelligence that folks go into. The Army, just a couple years ago, opened up the cyber branch. So a lot of my students end up branching cyber. So their day-to-day job will definitely vary wherever they're at. But as a second lieutenant, they can expect to potentially be in charge of a platoon, which is anywhere from a dozen to 4 dozen soldiers, and all equipment that they need to do their jobs, or potentially be on a staff somewhere, helping prepare reports or briefing majors and lieutenant colonels and colonels. And the vibe I get is that when folks transition out of the military, there's a concern from some of them that, they don't necessarily have marketable skills, depending on kind of what their branch was. But maybe way younger than they really has any business being. The Army entrusts the officers with personnel and equipment and, the authority to get the task done that they've been assigned.
HP tried to make me a manager really young, and I'm so glad they failed. But that was me. I wonder, part of me wonders if I had gone for the MBA, master engineering that they wanted, the split program that they wanted to sign me up for. And what would my life have been like if I had done that? It seems... Well, I mean, it's only been recently that I've discovered how much of a people person I am not.
Really?
I always thought it was just that I had a short temper. But the truth is, I don't like anybody.
Wow. This is...
Oh, I'm sorry.
Where is this coming from?
No, I mean, I think about the management that I've done, and I am happy with what I've done. And realizing that what I needed to do was different in engineering than in management. But it's taken a lot for me to admit I am not necessarily the best person to be a manager, because I do tend to get too attached to the people who work for me, and I end up antagonizing the people I work for. And so that's, it's just not really the right spot for me. But knowing that after college, I definitely did not know that.
Antagonizing the people I work for was my brand.
I know. That's kind of the Harvey Mudd brand,
but
really.
They deserve it. Going back to executives.
It is. You say I can't do this thing? I'll prove to you I can do it.
It's usually the other way around. You want me to do what? When? Legally?
Okay, so let's see. Did you have any more questions for us?
He probably regrets the ones he's asked already.
Yes, I know.
Yeah, I got one more. I mean, as long as I've got a captive audience. Tell me about your Mud experience. I mean, I think when I was first on the Slack, I mistook how how much time there was between our grad years. But I just love talking to mutters. I couldn't believe there are two mutters in the EECS faculty. I couldn't believe it because the place is so dang small.
When did you graduate?
2010.
So let's see. When was the last time we were there for a walk around? 2011, I think. So probably okay. So I think you guys had it good.
A cafeteria?
Man.
Your cafeteria was fantastic. You had that giant maker space with
that new maker
basketball
space thing
court.
and
Oh
the
my
gym
goodness.
thing.
All we had there was a muddy field.
Some nice buildings. At least one more dorm that didn't smell like the 70s.
You're short a pool, but realistically, we could only swim in the pool when it was closed. And, then eventually campus security would come and
I never
yell at
swam.
you.
I never swam in the pool. I was supposed to take the swim test, but I managed to evade it long enough that they took away the requirement.
Nice.
I think Mud was definitely in a transition period when we were there between
we still had Riggs, and he was a
Hank
very
Riggs.
different president.
It was a very, legacy of the 80s kind of thing still. I mean, it was 1992 when we started, so it was basically the 80s. So kind of 70s, 80s attitude toward engineering was still persisting. Some very, how do I say this politely? Some very venerable and distinguished professors in many departments teaching classes that perhaps they should have moved on from.
They were the OGs, the people who started when the college started in 1955.
Some of the people were people who started when calculus started. I'm being really mean, but no, when we started, there were definitely newer faculty were just starting to come in who had, fresh ways of teaching, and, it was very much a transition. So some things were very good, but I think some things were beginning to be on the upswing of improving, and we kind of missed it.
What was the gender ratio when you went?
My first year was Maria Klauer's first year, and that was a big, from what I understand, big focus. So it was climbing, I think, the whole time we were there, but it was, I want to say, like in the 35-40% range.
I think it was
15 to 20 for us.
15-20%. Yeah, it was low.
Yeah, they made a lot of progress.
Yeah, I there's many things I loved about Mud. And there's many things that took me years to forget about.
And many of the mutters I met then are still my best friends.
Yeah.
I married a mutter.
That's the way to do it.
And I mean, and when you were there, they had already kind of revamped the curriculum too, because the way they did the core when we were there was much different, I think.
Was it?
Yeah, didn't they redo all the core courses and stuff, and put a greater emphasis on? Oh, gosh, I can't remember what they did, but there was more flexibility about where you could take stuff. There's a little bit more greater emphasis on some humanities stuff, but also, I don't know if there were some courses like they were thinking of not requiring for engineering, like PChem and other stuff.
We didn't have to take PChem or OChem.
Okay.
Those were on my list, but they could never fit in.
All right. Well, I know there was some revamp, because I remember going down there and they were talking to alumni about, here's what we're going to do. And alumni were like, you can't do that. We had to suffer.
There's a phrase at West Point called "the core has," and it's just the idea that I got to get the opportunity to go to Ranger School, and they keep talking about everyone went through the last hard Ranger class.
Yeah.
So I try to keep an open mind about that stuff.
Yeah.
And for folks who don't know what Harvey Mudd is, when we talk about the core, the school has only a few official majors, and they're science and engineering based. So when we talk about the core, these are the classes everybody has to take. And they're things like physics and chemistry and biology and math and CS.
Calculus, and
and so when we meet other mutters, we know that they have that level, plus 1/3 of their courses were humanities of some variety. And so it's a weird engineering balance. But it also means that while Nathan has an engineering degree and Chris has a math degree, they both can talk about that bucket lab.
I didn't do, no, bucket lab was Z54. I never took that.
Nathan did.
I wasn't in, yeah. No, I took one engineering class and noped out of that major. I have to work in groups with people on projects? No.
Well, what I loved about this school too is I used to tell folks on tours, the kind of individuals who are just gonna, they're gonna run circles around me at the chalkboard, and then 2 hours later, I'm gonna see them zipping by on their unicycle, and we're gonna grab a beer after class. Or
right.
Something. Like, they're individuals who are crazy smart, but have not somehow lost that like social side of them.
Yeah.
Expressive.
Odd.
Okay. There.
Let's just call it as it is.
I was trying to say that.
So do you have any ideas for future talks?
After the last Embedded Online conference, I kind of jotted down, some thoughts. But I think it's going to be whatever's the project I've most finished and most excited to kind of share. I love, something that excites me. That's just kind of who I am. I want to be like, hey, check it out. Look what I just did. Let me show you how to do it. But I love that. I just love that the continuing of the maker culture with more Arduinos and more Raspberry Pi variants, and now MicroPython and CircuitPython. I got to help take our Cyber Fundamentals class from into a CircuitPython based project, which I was really excited about to kind of get these students some hands on with the hardware. So anything that's just going to help folks build cooler stuff faster.
That's kind of a motto: build cooler stuff faster. And Nathan, it's been really good to talk to you. Do you have any thoughts you'd like to leave us with?
Yeah, I'll leave you with one, which is I think it's Isaac Newton who said something like, "If I see so far, it's because I stood on the shoulders of giants." So just a huge thank you to the two of you for the work you do in helping folks learn embedded systems. Huge shout out to individuals that I've had the opportunity to meet through the Slack, like Chris Feck and Phil Johnson, and everybody on the Slack channel who's put up with my inane questions. Thanks for helping out me and other individuals.
Our guest has been Nathan Jones, an active duty Army officer and instructor at West Point.
Thanks, Nathan.
Thank you both so much.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group for all that they do. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now I have some facts, which may be of dubious quality, but I got them from a book, so I'm going to call it facts. The book is How to Speak Whale by Tom Mustill, and it's about etymologies. So whales are cetaceans. That's dolphins and whales and orcas and all that. And cetaceans, if you go back to the Greek, means large fish or sea monster. So there are two big kinds of cetaceans. One is the ones that have teeth, and these are the Odontoceti, which literally means sea monsters with teeth. Makes sense. And then there are the baleen whales, which a big part of the baleen whales are the Mysticeti, which, according to the book, means sea monsters with mustaches. Anybody out there knows Greek? Please let me know if that's true, because I want it to be true. These are all the baleen whales. They do the filter feeding. Sea monsters with mustaches. It's great.